Hello and welcome to this video tutorial. Today we're going to take a look at skills practice 6.1, projectile motion. Please remember to pause or rewind the video as needed. Let's begin. Read along with me, please. Projectile motion has vertical and horizontal components. So what is a projectile? A projectile is something that flies through the air and curves down to the ground. Well, why? Because gravity is making it curve down to the ground. So if you read along with me, it tells us that projectile motion has vertical and horizontal components. That means it has a horizontal direction to velocity and distance, and it has a vertical direction to velocity and distance. Gravity affects the vertical part. When we drop an object from height, we know that its speed is increasing as it falls. The increase in vertical speed is due to the acceleration due to gravity, little g, 9.8 meters per second squared. You, ladies and gentlemen, might remember that we round this up to 10 when we do our work. So the vertical speed of the ball increases by 9.8 meters per second every second. After the first second has passed, the speed will be 9.8. After the second has passed, 19.6, and so on. The acceleration of gravity affects only the vertical component because gravity points down. It doesn't point in the horizontal direction. So horizontal motion is not affected by gravity. So if we neglect the friction from air, when we throw an object horizontally, the horizontal speed will not change. In other words, ladies and gentlemen, we're going to be doing a projectile motion problem with constant speed in the x direction, and we're going to be doing constant acceleration due to gravity in the y direction. Okay? Let's scroll down for a bit and let's annotate a few things before we begin. I'm going to scroll down past these examples here. Okay, so what are some of the things that we need to know? You need to know what our basic variables that we're going to be looking at here. X, Y, Vx, Vy, G, and T. Okay, we're going to be looking at those. X is the horizontal distance of a projectile in meters. Y is the vertical distance. Horizontal distance, you can think of how far away. How far away is X? Vertical distance means how far below. How far did something fall? So both have a unit of meters, but one of them is how far away, the other one's how far below, because you're dropping a certain height. Vx is the horizontal speed. In meters per second. Vy is the vertical speed. Also in meters per second. G, we're going to round up to 10 meters per second squared. That's the acceleration due to the force of gravity. And T is, of course, time in seconds. Okay, so as we do this, we're going to be using the following three equations. And we numbered them in our formula sheet last week as equations 9, equation 10, and 11. Equation number 9 was X equals Vx times T. Equation number 10 was V sub Y equals GT. And then finally, equation 11 was Y equals 5T squared. Those were the simplified versions of the equations that we used for constant speed and constant acceleration motion, specifically applicable to projectile motion. So before we begin to do any work, let's go down to the problem-solving boxes below, and let's make sure we number them off accordingly. So here's box 1, 2, 3. Okay, and on the last page, we have problem 4, problem 5, and problem 6. Here we go. So now that we have our problems identified accordingly, let's go and annotate the question number one. So we're going to start by annotating each question. Then we're going to fill out the appropriate boxes in the problem-solving boxes. Then we will choose the correct equations. I said equations, plural. Since we have two directions, x and y, there's a chance that we could be using two different equations to solve these problems as well. So we have to pick the correct equations and then solve for the appropriate things that we're looking for. So read along number one with me. A cat runs and jumps from one rooftop to another, which is 5 meters away and 3 meters below. Calculate the minimum horizontal speed with which the cat must jump from the first roof in order to make it to the other. All right, so I read this and I read this. Okay, and we're looking for this. Now, this word here gives away a lot. Away tells me that 5 meters is going to be x, and 3 meters below tells me that 3 meters is going to be y. And horizontal is in the x direction, so minimum horizontal speed would be vx equals question mark. So those are the three things that were given in problem number one. Let's go down to box number one. We are looking for vx. We are given x is 5 meters. We are given y is 3 meters. And you'll notice, ladies and gentlemen, that the only equation that has vx in it, when we go back up to our equations, the only equation that has vx in it is this equation here, number 9. So let's go ahead and use equation number 9. Let's write that down in our box. We know we're going to need it. X equals Vx times t. But, ladies and gentlemen, you'll notice that in order to solve, you're trying to solve for Vx. In order to solve for Vx, you have to get rid of time. Notice you don't have time, at least not yet. So here's what we can do about that. We can choose a second equation for our list above to find time, and then we can plug that into our first equation and find Vx. So what equation could we use to find time? Well, here's my hint to you guys. How about let's find an equation that has y in it? Y and t. Which equation above has y and t? Well, that would be equation number 11, has y and it has t. So let's use equation number 11 to find the time first, and then we'll work backwards to find Vx. Okay, so we're going to use y equals 5t squared. Okay, there we go. We're going to we'll use that one first. Y equals 5t squared. Now, in order to solve for t, we have to get rid of 5 and squared. So I'm going to divide both sides by 5. That's where I'm going to start. Rewrite the equation, and I get y over 5 equals t squared. Now I have to get rid of the square. Well, the opposite of a square is the square root. So I'm going to square root both sides, and t is equal to the square root of y over 5. Go back and look at your given. Y is 3 meters. So I'm going to take 3 divided by 5 in my calculator. Okay, and I get 0.6. 3 divided by 5 is 0.6. Now I have to take the square root of 0.6. The square root of that answer, and I get a time of 0.77 seconds. And that's not my final answer. I'm looking for Vx. But you might remember I need time in order to find Vx. So now I'm going to take my equation, x equals Vxt, and I'm going to solve it for Vx. Well, I can do that, ladies and gentlemen, by dividing by t. Okay, so Vx is equal to x over t. X is going to be 5 meters divided by 0.77 seconds. And you get about 6.5 meters per second squared when you put that in the calculator. Again, if any part of the problem-solving process went a little too fast, make sure you pause or rewind the video as you need to do so, okay? Let's take a look at question number 2. Question number 2 reads, an object is thrown off a cliff with a horizontal speed of 10 meters per second. That means this is Vx because of the word horizontal. After 3 seconds, that would be time, the object hits the ground. Find the height, so y equals question mark, and find the total horizontal distance, x equals question mark. So we're given 2 things, and we're asked to find 2 things. Therefore, you're going to need 2 equations. Now, to make this really easy, guys, you're looking for x and you're looking for y. So the 2 equations I'm going to use would be this one that has x in it and this one that has y in it. Let's go down to problem-solving box number 2 and fill out what we're given. Let's see here. We are given 10 and 3. Okay, so we are given 10 meters per second, and we are given 3 seconds. Okay, we are looking for x, and we are looking for y. We can use x equals vxt and y, this is both of them, and y equals 5t squared. So I'm going to split the box in half since I have 2 solutions. X equals vxt. And we can directly plug in because we are solving for x and y. And you'll notice we're solving for x and y. This is already solved for x. This is already solved for y. So we can directly substitute right into our equations. Vx was 10 meters per second times 3 seconds. X means the projectile landed 30 meters away. Okay, that's what the 30 meters stands for. The second one, y equals 5t squared. We're going to go 5 times 3 squared. Now, when you put that in your calculator, you guys have to remember to do the squared part first. Squared means multiplied times itself. So 3 times itself would be 9, times the 5 out in front would be 45 meters below. So in other words, it falls 45 meters, but it lands 30 meters away. Those are our 2 solutions for number 2. Number 3. A marble is released from a height of 10 meters. How long will it be in the air before it hits the ground? This to me doesn't even sound like a projectile problem. This sounds like a free fall problem. You have a marble that's simply falling, right? Okay, so how long will it be in the air? What are we looking for? How long would the time? We are told that it's released, I think it's 10 meters. Yes, 10 meters. So we are given 10 meters high. And the only equation that has y and t in it would be y equals 5t squared. And let's use that and we'll solve it for time. Now we did this already in equation number 1. You might remember, what did we do to solve for time? We divide by 5. Right? Y over 5 equals t squared. Then you get rid of the square by square rooting both sides. And t equals the square root of y over 5. Which now we plug in our y. Y is 10. So we're going to go 10 divided by 5, which is 2. All right. And we want to take the square root of 2. Square root of 2 is about 1.4. It takes about 1.4 seconds for that ball to land. Okay, number 3, fairly straightforward, really just a free fall style problem. But again, remember, the projectile motion, the vertical component is free fall acceleration due to gravity. Number 4, a skier competing for Olympic gold wants to jump a horizontal distance of 135 meters. So that makes this X, right? Word horizontal. The takeoff point of the ski jump is at a height of 25 meters. That makes this Y because of the word height. With what horizontal speed, Vx, must he leave the jump pit? So we're looking for Vx. We're given 135 and 25. Okay, we're given a height of 25 and a horizontal distance of 35, and we're looking for Vx. Okay, so again, the only equation that has Vx in it is x equals Vxt. But you might also remember that in order to solve for Vx, you have to divide by time. We don't yet have the time. So just like we did in question number 1, we're going to need equation number 11, which has y in it, and solve equation 11 for time. Let's do that first. Y equals 5t squared divided by 5. Y over 5 equals t squared, square root. Okay, t equals the square root of y over 5. Now, y is 25. So we're going to go 25 divided by 5, which is of course 5. But then you have to square root that. Square root of 5 is about 2.2. So it takes about 2.2 seconds to land. Now we take that 2.2 seconds and we put it into the second equation. So take the second equation, x equals Vx times t, but you have to solve it for Vx. So we'll do that by dividing by t. Vx equals x over t, which would be 135 meters away, divided by 2.2 seconds. And 135 divided by that gives us about 60 meters per second, which just as an equivalent, that would be over 120 miles per hour. Okay, so again, here's question number 4. Again, if you need to see anything a second time, please make sure you pause or rewind the video as you need to. Let's go back to question number 5. Question number 5 reads, a motorcycle stunt driver zooms off the edge of a cliff at a speed of 30 meters per second. Off the edge of the cliff would be horizontal. That means 30 meters per second is going to be Vx. If he lands at 0.75 seconds, that is time. What is the height of the cliff? That would be y equals question mark. Okay, so we're given 30 meters and 0.75 seconds. 30 meters, 0.75. So 30 meters per second, sorry. So Vx is 30 meters per second. Time is 0.75 seconds. And you're looking for, go back and take a look, you're looking for height of the cliff, you're looking for y. So the only equation that has y in it is y equals 5t squared. And what's beautiful about this is it's already solved for y, which means you can just substitute directly into the equation. We don't need to rearrange anything. So 5t squared would be 5 times 0.75 squared. Okay, now, when you put this in your calculator, make sure you square the 0.75 first, meaning 0.75, square it, then multiply times 0.5. Do that first. Okay, and if you do that correctly, 0.75 squared is 0.5625 times the 5 out in front. That's about 2.8 meters. As you can see, some of these questions have required 2 formulas. Sometimes they don't. Okay, but we know we only have 3 equations to choose from, which does make it pretty easy. Number 6, last and final question. Please read along with me. A marble rolling at a speed of 2 meters per second falls off the edge of the table. Well, that's the speed that you're leaving the end of the table with. Okay, so if you were kind of to examine a picture, if here's your table and there's your marble is going to go off the edge horizontally. So we want to make sure we are labeling this correctly. That makes 2 meters per second. That's going to be v sub x. 1 meter high is the keyword table that makes this y. How long? You're looking for time. You're looking for time. So we have 1 meter, 2 meters per second, and we're looking for time. Okay, so there's our given information. 2 meters per second. Y is 1 meter. We're looking for time. The only equation, we've mentioned this a lot already, that has y and t in it would be our equation number 11, 5t squared. So y equals 5t squared. We've solved this for t a few times already. Go ahead and divide away the 5. We have y over 5 equals t squared. Go ahead and square root to get rid of the square. And time will equal the square root of y divided by 5, which would be 1 over 5. Now, 1 over 5 is 0.2, but that's not the answer because we're taking the square root of 0.2. Square root of 0.2 gives us about 0.45 seconds. Something I want you, ladies and gentlemen, to notice as we conclude this particular lesson. Notice we're given Vx in question 6 and question 5. Both questions were given Vx, but notice we didn't need to use them. So sometimes you're given what's called extraneous information, meaning you're given extra not needed information. And in the case of questions 5 and 6, that was definitely the case. I hope you found this video tutorial helpful, and thank you.